Sorry I didn't record anything up until this point, but great, Toyin. That works very well. So we want the names of sailors. So let's go ahead and project their names. And we are concerned with two different relations here. So there's the sailors' names. So we're getting S name. So we're getting the names from the sailors table, and the boat ID from the reserves table. So we need both of them together. This is going to create one big mega table that has 3 plus 4, 7 columns of all possible combinations. And we want of these, this is like doing a natural join. So we want the sailor whose name this is to be the same sailor that reserved the boat. And in addition to that, the boat ID was number 103. Great. So this is, I think, the more clear way of doing it. But to give an example of something that's not too difficult and when you can use nested things, from this outer table, you can think of this like the outer loop. We're just going to be going through the sailors, their names. And you need this to be the outer one because here you're selecting the name. And so this name is being pulled from this sailors table. So the sailors S needs to go for the outer loop. And we only want to take the entries in the sailor table where the SID is, and now we're going to be printing this. This SID is in select r.sid from reserves r where r.bid equals 03. Okay. Oh. So these two queries do the same thing. Or rather, they have the same result. The way they go about it is a little different. Again, this one on top will create a big mega table with s.sid, s.sname, all the way. It'll also have r.sid, r.bid, and r.day. So this is a cross product, and you get this big mega table. And then the where part is making sure that, here I'll just use colors. So if we have red and blue, then here you would have would work like this. So red is matched with red is also matched with blue is matched with red is matched with blue. So this is all possible combinations. And we only want to keep those rows where the colors are the same. So here, red is not equal to blue. Here, blue is not equal to red. And in addition, we only want to keep the ones where the bit ID is a number that we care about. So maybe this was 103, and this is, I don't know, 200. So then this table, or this is just going to return this first result. And so this one gets eliminated because the BID is wrong. Now, this lower query works a little differently. First, it finds a set of RIDs where, or r.sids, sorry, r.sid, where r.bid is equal to 103. So, oh, sorry about that. Each of these, this is going to be a set of IDs. So here, I guess using the example above, this will just be a red dot. Because blue never reserved boat 103. So now this set only has one element in it. And then the outer loop is going to, from this set, look at every single element. So just pretending that this had many, many sailors who reserved the boat, then each one of these elements is just going to be a sailor ID. And the outer loop is after constructing this set. This part constructs this set. This part checks every single element of this set for some condition. And it iterates through the entire set. So this is kind of like that table, where first you have rows, but here the row is constructing a set. And then the inner loop, the looking at each element in the column space, is looking at each element in whatever this table is that you get returned. Is that clear enough? Are there questions about that? Will group it be on the final? No. I was planning. I messed up. Like I didn't realize that the reading day started from today, and that the last class was yesterday. So I had sort of saved this part, the inner loops, and the group by, and I will go over when and why to use the group by. Also mins and maxes, but those I think are pretty straightforward. I don't need to do much explanation for them. So yes, I put that on the final exam sheet because that's what I was planning to have, but no, if anything that I talk about today will not be on the final, only things that I talked about from the last lecture going in the past. Okay. Let's see. Just for some practice with this, and then I'll go into the group buys. here, actually we only need one relation. And I talked before about why I wanted you to rename things. Why one of the things that I was insisting on is that you rename your tables each time. It's especially for the case when you're referencing the same table. And so this is going to be an example of that. I'll leave this up here because the query is going to look something very similar to this. But you'll be using a max operator. So if you do a select max of, for example, s.age, instead of printing all of the ages, if you just had select s.age, it would print a list of ages. This will, from that list, pick out the maximum element. So using this relation, here's the query. Find the oldest sailor. Oh, find the name, sorry. Find the name of the oldest sailor. Okay, Eric, yeah, this is part of it. So this is finding the eldest sailor, but it doesn't give you his name. So, here. And I guess this is another point I should make. Because we want the sailor's name from S. And that sailor's name is going to be coming from that table. Okay, so there's a couple things that I want to note here. First of all, before I get into semantics, this inner one, as Eric pointed out, is finds the maximum age of the sailor, but then the name sort of gets lost because this select is just going to be returning a number and not a table that has other information. But you can use that number to then query the table and select the element whose age is equal to that number. Okay? So, yeah, some other things I want to point out here. First of all, this where true, it's optional. Here I put it just to remind you of that. You don't necessarily have to have that, but I don't know. I kind of like it. I think it makes it more complete. And on your final, you can have it either way. Like, that's not something I'm enforcing. Oh. Yeah. Here, because we're referencing the same table, I think it makes it easier to, it will avoid conceptual mistakes. Like if you're referencing things and yeah, you are, anyway, this is indicative of the types of queries that can kind of blow up in size, where renaming will help you avoid making mistakes. The last thing is here that I didn't use the word distinct. And I said before that you should always write distinct unless you have a good reason not to. And here, this aggregation is going to be choosing just a single element anyway. So it's not needed. The max is going to be returning one number. Oh, I guess that's another thing to mention, is that this seems like a little bit of an exception, because here in this up above, you could potentially have a whole set of sailors who reserved boat 103, and you want to print all of their names. Here, the whole set is just one element. It's just going to be one number. So you might still print off multiple sailors' names if they all have the exact same age. But this query is just going to be returning a single element. And because of that, the distinct isn't needed. Also, if you're doing things like, let's see, like if you're taking an average, for example, if you're taking an average, then you might not want to use distinct elements, because maybe repeats will affect the average, and so you actually want them to be counted. So really for these types of, these are called aggregations. So when you take a collection of especially numbers and you perform an operation on that collection, maxes, mins, averages, that could be the mean, that could be the mode, the median. When you're doing sort of statistics, then in that case, you might not want to use distinct. So I thought I'd mention that. Okay. Let's see if there's other things I want to cover before group by. Oh, just so you know, some of the aggregations, you have max, you have min, you have average, you have sum, you have count. Yeah. And anyway, when you're doing those, you should think about if you want distinct or not. In the case here, it doesn't matter for the max. Okay. So here, let me go back to this example. And I'll go over it again, just to reiterate the nesting thing. So here we want to print student names such that their grade was an F and their age is the minimum element among all students who received an F. Okay. Here you can say in, or you can say equals. Doesn't matter. So this will find the age of the youngest student who received an F, and this will print the names of the students who have that same age and also received an F. I got a question. Can I delete this? Is this needed? If I'm checking here, do I also have to have this check for the F here?
I think you still do, right? Because it still needs to check at least first to make sure that the grade equals F, and then it can go into all that. Or how does that work?
There's another reason for it. You do need it. So the problem would be if, let's see. If this person was 20 and this person got an F, then what I want this query to print out is Donald Duck, because he's actually the only person who got an F, not only the youngest. But what this is going to do is just return his age. So this is going to return the age of the youngest student who received an F. So this is going to return the number 20. And if I deleted this second check, then this will print all students whose ages are 20. So this would print Peter Pan and Donald Duck, even though Peter Pan got an A, but because their ages were both the same. So that's why you still need to have this check here. So this finds the age of the youngest student who got an F, and this is checking that from this table students, not only is that their age, but in addition to that, they got an F. Make sense? Great. So, as I was saying before, if you wanted to answer this, one way you could do it is to just develop a very, very lengthy query. So this is going to check for Fs, then I'm going to union that with D minuses, and I'll union that with the C or the Ds, and then I could have, I don't know, however many that would be, 12 lines or something. So 12 of these types of blocks, all unioned together. But there's a problem when if you have too many of these grades. So here 12, maybe it seems manageable, but what if there were 1,000 different grades? Or if I wanted to know something like, I don't know, for every taxpayer's annual income in the US, the Social Security number of the youngest who hasn't been audited yet. If I had a query like this, then this is just, I mean, you're not going to do this by hand. For every taxpayer's annual income from, I mean, even if you make it in multiples of 10,000, so 0, 10,000, 20,000, 30,000, 40,000, 50,000, I mean, you're going to be going up into the billions. And you're not going to do that by hand. Or maybe it's an infinite thing. There's not a fixed set of steps to it. And that is where this group by comes from. So let's see. This is something that's simpler. For each grade, FD minus D plus A, find the youngest student age together with the grade. Let's type up the query as well. Okay. So this group by, I'll write this by hand. Okay, so group by is the same as for every grade, for each grade, you're going to run a new SQL query. So for each grade, you're going to run the same SQL query. And each time you run the SQL query, this table, students S, is going to be restricted to those that have this grade. Any questions about that? No. Okay. Oh, no questions. I'm sorry. I forgot if I asked if there's any questions or if you understood. Are there any questions about this? Okay. Then All right, let's try to build on this then. Okay, so this is a simpler query, not the original one that we asked, which is this. So I'm going to copy that relation again. My name is student name. So, okay, let's take this. If we did this, this will return the age of the youngest student in each group. So the age of this will return a set, 30, 25, 16, 24, whatever, where these are the ages of the youngest in that group. So the youngest who got an F was 30. The youngest who got a D minus was 25. So this we can kind of build on if there's going to be something wrong with this. I want to see if you can catch it. Okay, so that's it. What is this query returning? Don't you need to select distinct? Oh, sure. Now there's something more substantial than that. Thank you for catching that, though. Not sure. Okay. Here, let me take this table up here. Move these things over. And for this table, what would this return?
Hey, Professor, I think I can give this a try.
Yeah.
In this case here, with unique ages, it'll give us the answer we quote unquote want, where it'll give us the lowest ages by the way we have it set up grade. But I
Yep.
think what the original question was, and the answer to that would be that if we start having duplicate ages now, in the
Hmm.
second query, while we're able to break them down by grades, similar to the error I made the first time around, if we transfer them over, we're only getting ages now. So if we have duplicate ages, we're just getting names that match those ages, but not necessarily by the grades that we wanted to group them by.
Yeah. Perfect. Yes, exactly. So there was it's a similar thing to what happened up here, where this what would have happened if you deleted this check? How that would return both Donald Duck and Peter Pan because their ages matched. But by the time it gets to this outer query, the grade has been lost. This part just returns an age. So similarly here, this is sorry, scroll down. Right, group by s2.grade. Here for grade C plus here, or no, let's say grade B plus. Grade B plus, when it gets to that part of the group by, then it's going to be choosing the age of the youngest person who had a B plus. That's Mickey Mouse. And he's aged 30. So then this inner part is going to return a set, right? And so this set, first of all, the youngest A is 20, Peter Pan. C plus, the youngest is 25. B plus, the youngest is 30. And that's it, right? 3 different grades, yeah. So this is going to return this set, 20, 25, and 30. And the way that this is written right now, it will print the student names who have these ages. So this will go through this table and look, is 20 in the set? Yes. Okay, I'll print Peter Pan. 25? Yes, I'll print Donald Duck. 30? Yes, I'll print Mickey Mouse. 35? No, not in the set. 40? No, not in the set. 30? In the set. Print Amy. And so Amy shouldn't be included in this. Okay? So, in order, well, any ideas how to fix this? It's a relatively small fix. Okay. For the sake of time, because I certainly don't want to keep people any longer, although I'm happy to keep chatting if people want. Here, where this fell apart is that this set is only returning numbers, just ages. And so when we got to this outer part, we've lost the connection with the age and the grade. So what we would like this to return is, instead of just these numbers, it could return tuples. And it could tie together that 20 like this query up here, finding the student age and tie it together with the grade. So now we're saying that for grade A, the youngest was 20. For grade B, the youngest was 25. For grade C+, the youngest, I'm sorry, the youngest is 30 for B. Wait, what? B+, the youngest is 30. And for a C+, the youngest is 25. This is what we would like. We're going to tie the grades to the ages. So here you can return both the age and the grade. Let's move this over this way. Okay. And so now this is going to be returning this tuple. And now here you just check for that tuple. So s1.age and s1.grade. So now is this tuple in this list? And now when we print, this information is retained, the connection between the age and the grade. Any questions about that? I'll take the silence as a no. Yeah, so the only other thing, there's one last example. So that I can go through very quickly. Find the youngest student name and grade only when there are at least 2 students who got the grade. So this is just another operator. So first of all, you want to print the name and the grade. There's only one table here that we are concerned with. And we want the grade and the age to be inside of a tuple. And here we're building what that tuple looks like, where it's grade age. Same table. And here, again, we're building this set element by element, going over each of the grades in turn using the group by. And here, so this having count only applies to grouped attributes. You can spend some time thinking about this. I won't go over it because I know that time is already kind of here. This is just sort of an extra to give you. The main things that I wanted to cover were this idea of nested queries, because that's very important and you'll see it, and also group by, which you'll also see, and it's very useful. This having count is, yeah, like I said, just sort of extra. Yeah, what I'm more concerned with is, at least for those who attended this sort of extra lecture, if you feel like you have a better grasp, or if you feel comfortable with aggregations, I think that those are pretty easy. But this nested nature of things and why group by exists and how to use it. And other than that, any other questions about the class in general, or comments, or anything?
Yeah, Professor. I just had two quick questions about topics that I looked over the weekend about the final exam.
Mm-hmm.
The first one I had was about foreign keys. I understand that foreign keys, when they point to primary keys, they can't be null because that primary key needs to be an entity. Would it be safe to say that all foreign keys can't be null or should have the not null indicator?
No. Yeah. So, uh, it could be the case that you want to retain a record of so let's see. Maybe I'll use the same insurance policy thing, because we use that example in class, where you have an employee and then they have a, like an insurance policy that covers them and some beneficiaries. And here, in that example, we were saying that if the employee leaves the company, then this policy should also be removed from the company's rolls. And so then we should have it be not null. When an employee leaves, then that insurance policy gets pulled. But maybe for legal reasons, the company could have two tables. One table of active policies that the company is paying for, and then another is a history of policies. And maybe they'll retain that for 6 months. So if an employee leaves, they're removed immediately from the active policy table, because the company isn't going to be paying the insurance policy anymore. But they still want to have a record of this policy existing that was on their payrolls, and maybe how much they paid for it, so that they can do accounting later in the year or something. So in that case, the second table would also have a foreign key that points to the employee ID, but when the employee leaves, then that record should be retained.
But in both cases, would that policy still be a primary key?
I see. No, it's okay. So I'm sorry. Yeah, you're right. That's a different example. That's for deleting. So let me think. Maybe a better example would be if there is people have different offices in the building. Similar scenario. There's an employee. There's a company. They have a number of employees. They have a number of offices, and each of these offices have perks in them. When a new employee comes in, then they can ask for maybe a coffee machine, maybe an extra monitor, a space heater, extra stuff. And so there's going to be a table that has the employee ID and that's going to be the foreign key to the employee whose office this is, along with attributes of, is there a second monitor? Is there a space heater? Like what stuff is in the office? And now when the employee leaves, then the ID can go to null, which means that this stuff still exists in the office. You don't want to lose track of the physical things that are in the office. But if you look at the SID and it says null, then that indicates that it's an empty office, that this is some like an office that now somebody could be assigned to. Or maybe for all of them that are null, in some amount of time, a cleaning crew can go up and start taking things down and putting them back into stock or whatever. But in any case, you're actually using the null here to represent an empty office.
I see what you're saying there. That clarifies my question on that. And then the other one I had was I understand that the thick line is the one that there's a discrepancy between the ER diagram and the relational diagram. Is the solution or explanation behind that that the relational diagram simply can't capture this? We need an entry here, that kind of like function or statement.
Yeah, it's the other way around. Entity relationship diagrams can capture that because that's what it is. It's a thick line in an ER diagram. But the relational model can't, because there's no way to enforce that tables have to have the same size, for example. And this could be the case if you have, for example, two thick lines connecting the two entities to a relationship. Then here this results in having tables that need to be of equal size, that there has to be like a one-to-one relationship, but there's no way to enforce that in the relational model. SQL, you can do things like that. I mean, not with the queries and stuff that we've been using, but there's some extra machinery in SQL that allows you to do this, but the relational model can't handle that.
So to clarify, the ER diagram in the SQL can capture it, but it's the relational one that
Correct.
got you. And then that really covers it. The very last question I have is, I know that last class we're still reworking the weights for the class. Just to clarify, is it that it's just going to be a proration of everything, not like the final is just tacked on?
I'm sorry, say that again? It's not the final, it's just going to be tacked on, but what?
Would the weights just be all prorated, less the project? Like equal weights of what it was before, but just scaled up to 100%?
Yes. Yeah.
Okay. That makes sense. That's really all on my end. Thanks for answering my questions.
Sure.
Hey, Professor.
Yeah.
I have a question, not regarding the SQL material that we covered, but just like SQL programming in general.
Mhm.
This might be like a really dumb question, but I was just curious. My experience when coding in SQL, it was like through Microsoft Access. So we would just like input the SQL code through there. But obviously all the databases that we work with won't be on Access. So how would you go about where would you actually write the code for SQL depending on the database you're using?
So you can do it just through the terminal. So there's a MySQL client. So a SQL, like MySQL, if you download it, you can set it up on your computer and do all this stuff. There's the server, and this is actually holding all of the data and is where the tables are stored. Separately, there's another program called a client, and the client can connect to the server and then insert things into the database, it can query the database, but the server program that's running, that's what's receiving the commands and accessing the hard disk and then executing the query and sending the result back to the client. So the client, you could run it from a terminal, like directly. There's also like IDEs, like Microsoft Access is one example. I know a program called IntelliJ can do this. Probably Microsoft Word. Any of these types of they're called IDEs. In fact, well, maybe what you might have used PyCharm. I'm not sure if PyCharm can do this. That's just for Python. But yeah, you could either use a program or you could just sort of use a console program directly if you wanted to write like raw SQL code.
Okay, I see. Yeah, we had experience with IDEs with PyCharm. I think that's what we used.
Yeah.
But that makes sense. Thank you.
Yeah, so PyCharm's okay. Yeah, but I think that it's as its name would indicate, mainly just for Python development. And so, but yeah, you can run tests, and you have a console that you can run direct Python through. You can debug and stuff like that. So IDEs offer some extra tools. Other IDEs offer things like being able to connect to databases and run queries directly.
Okay, I see. Thank you.
Mm-hmm. Okay, I can see that there's still some people in the class. I don't know if you're just hanging around or if you have questions or you're just waiting for other people to talk first.
I just want to thank you, Professor, for the class. I mean, just for everything that's happened and stuff. Just to continue to keep teaching and stuff. I really appreciate you for that. Thank you.
Thank you. Yeah, that's very nice of you to say. I appreciate that.
Yeah, Professor Hobbs, thank you for a great semester, man. I think you know everyone had it hard, and you professors, adapted, and we appreciate that.
Well, thanks. I mean, I hope you had, you know, um, yeah, understanding professors and that things were okay for you guys, all things considered. I mean, I understand that things aren't, uh, party time nice or anything like that, but all things considered, I hope that people are making do. Um, yeah, it's a very strange period of time.
Yeah. Well, be well. Thank you.
Yeah, you too. Thank you.